Hi student, we have chapter 2 vector calculus and we're going to learn about vector and scalar fields. So keep watching this video. As we know, a vector is a quantity that has magnitude and direction. Vector is made of components which are scalars. For example, 2, 1, which also can be written as 2i plus j. So both 2 and 1 are scalars and we call those components. It doesn't matter what is the initial point or terminal point of this vector. We can move this vector around however we want and it will have the same magnitude and direction. Now we are going to introduce vector fields, which are a function that take in coordinates and give back vectors. So we have here a vector assigned to every point throughout the coordinate system. This is an example of 2 dimensions. So any point in this coordinate system P will be an ordered pair because it is 2 dimension, and we're going to assign at each point here a vector. Of course, we are not limited only for 2 dimensions. We have also 3-dimension vector fields. Each point here in this field, for example, this point will be an ordered triple, x, y, z. And we're going to assign a vector at every point in this 3-dimension. Vector calculus concerns 2 kinds of function, namely vector function and scalar function. So we're going to learn now about vector function because we're going to use it to define a vector field. Also, we're going to use the scalar functions to define a scalar field. A scalar function is a function whose domain is real number and the range is real number. That means scalar function takes scalar and give back scalar. Input and output both are scalar, which is real numbers. An example about scalar function is f of t equals sine t, and we can write it also as f of x equal sine x. And we can take t also time. For example, here, if we take the value of t pi over 2, so sine pi over 2 will give us 1. That means input is a scalar and output is a scalar. It is called a scalar function. What about a scalar field? Is an assignment of a scalar function to each point in a space. That means we can assign to each point in a space a scalar function. And in this another point in the space, we can assign to this point a scalar function, which is a curve. And so on. So we will have a scalar field. And our point here, maybe it is 2 dimensions, x and y. Maybe it is a 3 dimensions, x, y, z. So the vector field may be 2 dimension, maybe 3 dimension. But in the scalar function, it is 1 dimension only. So a scalar field is defined by a scalar function. Example about scalar fields are the temperature field in a body or the pressure field of the air in the Earth's atmosphere. We know that a vector is made of components, for example, v1 and v2. If the components are scalars, we simply call this a vector. But if the components are a function with a variable t, this is called vector function. Like for example, here we have x and here we have 2y plus 1. It is a vector which is 2 dimension. Definition of vector functions We can call it also vector valued function is a function whose domain is real number and whose output or range is vectors. That means vector function is a function with input scalar and output is a vector. And maybe it is 2-dimension vector, maybe it is 3-dimension. Like here, this is a 2-dimension vector function and this is a 3-dimension vector function. Component here, each one of them is a scalar function. And now a vector fields. A vector field is an assignment of a vector to each point in a space. That means we can assign a vector to each point in our space. If our space is 2-dimension or 3-dimension, for each point we can assign a vector. Maybe it is x and y, 2-dimensional space, and maybe it is x, y, z, that means 3 dimensions. So this is a vector field which is 2-dimension. This is a vector field which is a 3 dimensions. But in the vector function, it is 1 dimension. Input is a scalar which is 1 dimension. Here input is a scalar which is 2 or 3 dimensions. Examples about vector fields as shown here. This is the field of tangent vectors of a curve, so we have field of vectors. Also here, field of normal vectors of a sphere. We have the following example. Sketch the graph of the following vector function. As you can see, the input is 1 dimension, that's why we call it vector function. As you can see, the result is a vector which is 2 dimensions, so we have the xy plane here, and we need to have a table. We're going to assume the value of t, and we're going to get the vector v. Also, we're going to need x and y because we have x and y plane. So this is x and this is y. You can assume the value of t any positive or negative number. I'm taking 0, 1, 2, minus 1, minus 2. And you need to find x. X is t minus 1 and y is t squared. So x will be, if we take t 0, x will be minus 1 and then we get 0, then 1, then minus 2. If we put t minus 2 here, we're going to get x minus 3. The same idea to find y is t squared. So 0 squared, 0, then 1, then 4, then 1, and 4. So the first vector v1 will be minus 1, 0. Second vector v2 will be 0, 1. We get 5 vectors because we assume 5 values for t. Of course, we can take more. Let us take those as a position vector r, whose initial point is origin and terminal point is the given vector. So the first vector is started from initial point to minus 1, 0. This is v1. The second vector is to 0, 1. This is second vector. And then v3, 1, 4. This is 1, 4. It will be this vector. And then minus 2, 1. And minus 3, 4. So we get the following 5 vectors. And if we want to find the graph of the curve traced by the following vector function, we're going to get another example about vector function, but this time it is 3 dimension. So to sketch the graph of this vector function, we're going to need a table and we're going also to assume the value of t. And to sketch the graph, which is a 3 dimension, the input will be a number or a scalar, output will be a vector which is 3 dimension, which is 2 cosine t, 2 sine t, and t. T is a number greater than 0. Since t is greater than 0 and z here is equal to t, so our graph will be here in z positive, not in z negative. So this will be x, and this is y, and this is z. I, j, k are unit vectors, and r is our vector function, which is a position vector, which means origin of this vector is starting point of this vector is the origin. So I'm going to assume the value of t 0, pi over 2, pi, 3 pi over 2, 2 pi, because we have cosine and sine, and we cannot take minus pi over 2 minus pi because this is given in the question, a condition that value of t is equal or greater than 0. So I'm going to write the vector r as following. X is 2 cosine, y is 2 sine, and z is t. To find the first vector r1, we need to substitute the value of t0 here. So 2 cosine 0 is 2, 2 sine 0 is 0, and t is 0. Second vector, we need to substitute pi over 2. So 2 cosine pi over 2 is 0, and substitute pi over 2 here. 2 sine pi over 2 is 2, and then pi over 2. We get the following 5 vectors. We start from 0 to 2 pi. It's like one complete period. The graph here will be a vectors that traced by the curve circular helix. Circular helix is like this. The first position vector, which is initial point, is origin, and terminal point is 2, 0, 0. So 2 from x, 0 from y, 0 from z. It will be here, and the vector will be this one. This is r1. The second vector r2 is 0, 2 pi over 2. So 0 from x-axis, 2 from y-axis, and pi over 2 from the z with a rotation of 90 degree. This is, we have to have a rotation with 90 degree. It will be around of here. So r2, the second vector, is from origin to this point, which is 0, 2 pi over 2. R3, it is at the point minus 2 from x, so this is positive x. Minus 2 from x will be here, minus 2 from x, with 0 from y and pi from z. That means rotation from here to here, it is another 90 degree. And we're getting the following vector, R3. R4 will be at the point 0 from x, minus 2 from y, so this is minus y. Minus 2 from y will be here with 3 pi over 2 from the z. Okay, so it will be again a rotation with another 90 degree, and it will be around of here. And this is R4. R5 is at the point 2 from x and 0 from y and 2 pi. So this is 2 from x, 0 from y, and it will be around of here, because this is 2 from x, so it will be here with 2 pi. And this will be vector R5. The question is graph the curve traced by the vector function. So if we start from here and we graph the curve, reach to here and then here and this point, we finish one period, which is we start from 0 to 2 pi, then we continue with another period and we're going to get circular helix like this. So this is just one period because we start from t0 to 2 pi. You can take more to get another period, and it will be like this. So this is a circular helix traced by the vector function 2 cosine t, 2 sine t, and t. And this is how the circular helix will look like if we take more values for t. Thank you.